Welcome to 2-Minute Math with Dr. John, where we cover a math concept in under 2 minutes. That way, if you want to watch it again, it won't take too long. Now in this video, we're going to look at wholes in functions. Now, a hole in a function is technically called a PORD, or point of removable discontinuity. I prefer the term hole because it's much simpler. Now, a hole in a function is a lot like an asymptote, okay? Except whereas an asymptote is an imaginary line that the graph gets very close to but never touches, a hole is just a point. Okay, one point. The graph comes up to it and appears to go through it. In other words, it doesn't stay on one side or the other. But it just skips over it. Kind of the same way if you were walking along and there was a hole, you would skip over it. You wouldn't step in it. That point there, that hole, is where the function does not exist. Okay, now holes occur in rational functions, just like asymptotes do. All right, now when there's a common factor for x in both the numerator and denominator, a hole will be present. So let's look at an example. Let's say we have, f of x is equal to x squared minus 9 over x minus 3. Now we can factor the top into x plus 3 times x minus 3. All right, and that would be over x minus 3. Okay, the top is the difference of squares, and you should check out my video on that because it's really cool. Notice we've got an x minus 3 in the top and the bottom, so they would cancel out. We are then left with f of x is equal to x plus 3. Okay? So if we were to graph that, all right? In other words, we want the graph of y equals x plus 3. Okay, so we know that it has a y-intercept of 3. It has a slope of 1. Okay, so it comes down, dun, 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 just like that. Okay, where's the hole? Well, let's look back at our function, okay? And we go back to the original function. Notice there is an x in the denominator, and there is a value of x that would make that denominator equal to 0. We can't do that. So we must solve for that. X minus 3 equal to 0 means that x is equal to 3. That is the x value of our hole. Plug that into this one here where we have, f of x equals x plus 3, but our x is 3. 3 plus 3 equals 6, and therefore our hole is going to be at 3, 6. So we go to our graph. We find 3, 1, 2, 3, up 6, 1, 2, 3, 4, 5, 6. Here's our hole. And there's what our graph is going to look like. Okay. So I hope this video was helpful. Please like, subscribe, tell all your friends, and have a great day.